So remember, as I mentioned, I prefer if you guys can keep your video on, especially while we're doing our exercises. No problem, Shirish, that's fine. Right. So today's topic, or the topic that we'll be doing over the next 2 to 3 sessions, would be on computation and number theory. Right. So some of these things you would have recapped or you do know already, but I still need to just review them quickly with you. The first part is a lot of definitions. So we're talking about whole numbers, right? So generally, when we talk about whole numbers, we could refer to any individual number as a digit, right? So 1, 2, 3, 13, 21, all of these are digits, right? Natural numbers or counting numbers, they're usually denoted by this letter N. It looks like a letter N. It's not exactly a letter N, but it looks like it. Natural numbers are your counting numbers, right? They do not include zero. Whole numbers, on the other hand, and another word for whole numbers, the sign that is used to denote whole numbers, it's W, includes your zero, right? And then we have integers. Integers include both negative and positive numbers. Factors, when we talk about a factor of a whole number, it's a number that can divide another whole number exactly, leaving no remainder, right? Prime numbers are numbers that only have two factors, which is itself and one. So for example, 13, right? 13 is a unique number in the sense that the only numbers that could divide exactly into 13 is 13 and 1, right? 17 is another number like that, right? 5 is another number like that. 3 is another number like that. Those are all our prime numbers. If a number is not prime, then we say that number is a composite number, right? 1 is not a prime number. It's important for you to know that. And the only even prime number we have is 2, right? Now, composite numbers could be expressed as products of prime numbers, and we call that prime factorization, which we would look at shortly, right? Multiples is the opposite of a factor. So multiples of a number is numbers that another number could go into, is a product of the number, right? So for example, multiples of 2 will be 2, 4, 6, 8, 10, 12. You guys know that. Highest common factor, well, that's the largest number that is a factor of a particular number. The lowest common multiple, the smallest number that is a multiple of another number, right? And more importantly, instead of knowing it, we need to know how to calculate it, right? Index, this is where we write numbers to a particular power or exponent. So for example, if I have 2 multiplied by 2 multiplied by 2, right? We could write that as 2 to the power of 3. And that number to the top there is what we refer to as the index or the exponent, right? So for homework, I have 7 questions here for you to do. You'll be doing these inside of your notebook. As I mentioned, by tomorrow, I will send the PDF of the whiteboard notes in the Google Classroom along with the link to enroll or to join the Google Classroom. And you will do these inside of your homework book, and I'll leave an area for you to upload your work there. All right. So what I'm going to move on to is working with indices, right? Another very important area or topic in computation, because there's an overlap with this into algebra, and I have decided to introduce or to show that overlap here within our worked examples. So indices helps us or tells us that we are doing repeat multiplication, right? Repeat multiplication. So for example, when we have 4 to the power of 2, what we are doing here is you multiplying 4 by itself 2 times, right? If I have 4 to the power of 5, I am repeating that multiplication 5 times. Now, the number here at the bottom is called the base. This number to the top here is called the power, right? Another word for it is the index, and another word for it is the exponent, right? So this tells you the number of times the power or the index or exponent tells us the number of times that we are repeating that multiplication of this base number here, right? That's what it means, right? So if you want, you could just take a note of that. I would leave that up for you guys. Now, when we have multiple numbers, we could solve for these, right? We could solve for these. So we have 2 to the power of 2 multiplied by 3 to the power of 3. So we just need to work that out. 2 to the power of 2 is going to be 2 by 2. 3 to the power of 3 is going to be 3 by 3 by 3. And then we work those out. 2 2s are 4. 3 by 3 by 3 is 27. And then 4 by 27 is going to give us 108. Right? Just put this back here for you guys, in case anybody wanted to copy the name of the base and the power. Now, when we have algebraic terms and we want to simplify them, instead of writing a by a by a by b, we can use indices or powers or exponents to express this in a more simplified way. So we look at the number of times the base is being repeated, right? Now, we could only do this with like bases. So for example, what I mean by that is a by a by a, right? That's going to be a to the power of 3. B by b is going to be b to the power of 2, right? From algebra, we know we could join these together when we are multiplying. So a cubed multiplied by b squared will be written as a cubed b squared. Everybody okay with that? Just drop a 1 in the chat, but if you are. A 1 in the chat, but if you are. Right, everybody okay with that? Nice. Just change your name on your device, Samsung SM. So I know who's messaging in the chat. Right, and don't forget, guys, videos. I need the cameras on so I can see what you guys are doing. Right, so we're moving on. Similarly, when we are multiplying, right, algebraic terms, and we have the same base. In example number 4 here, the base is the same. I have A and A. All right, bases are the same. What we do when we're multiplying and the bases are the same, right? Same bases. When we multiply, we add the indices, or we add the powers. Right, so long as the bases are the same, if I'm multiplying a cubed by a squared, right, this is the same as writing out a by a by a multiplied by a by a. And this is why we can add it, because the bases are the same. It's not like the example that we had above, right, where we had 3 a's and 2 of the b's, right? We can't join those two together, but we could join those that are common. The a's we could write as a cubed, the b's we could write as b squared, right? And it follows that when I am multiplying and the bases are the same as in this example here, a cubed multiplied by a squared, I could simply just add the powers to the top. So what that would look like is this. I'll have just a, and I'm adding the 3 and 2, and I'm going to get a to the power of 5. And as you saw just now when I wrote this out, if we check the number of a's, we would get a to the power of 5. Yeah, just drop a 1 in chat, but if you're okay with that. Right, so same basis. When multiply, we add the powers. When we multiply, we put that in there. So that's number 4. The other rule, number 5, we call this one the power of the power rule. Right? Or index of an index or exponent of exponent. Here, what we are doing is we are multiplying. We are raising this power of 3 to the power of 2. Right? So a to the power of 3 raised to the power of 2. We multiply the indices. So we get 3 multiplied by 2, and we get a to the power of 6. Why is that so? It's like I'm taking a cubed and I'm squaring it, I'm multiplying it by itself again. And if I do that, if we expand this all out, I'm going to have a by a by a multiplied by another a by a by a. Right? And if I check all of that, I'm still going to get back the a to the power of 6. So instead of having to write all of that out, let's imagine if we had a to the power of 47, right, squared. You're not going to write a 47 times by itself another 47 times. That just would be impractical. So here, we just multiply the power by the other power. So you raise it to another power, and to raise it to the other power, you're multiplying. Similarly, it could work in an instance when we're not using algebraic terms, like I have on the side here. And let's just say that we are using numbers. So for example, if I have 2 cubed raised to the power of 2, I could simply just multiply the powers here. 3 multiplied by 2, and I get 2 to the power of 6. I could then expand that out, right, using my calculator. If I could multiply quickly in my head, I'll get 2 by 2 by 2 6 times, and I'll work out to be 64. All right? Everybody understand this one? This one is the power of a power. Right? Power of a power is the common name for it. Right? So you're raising the index to another power. Yeah? Everybody okay with that one? Drop a Y if you're right with that. Yeah? All right, nice. So moving on again. Another important rule that you need to know is when you have something to the power of 0, any number or any letter raised to the power of 0 is always equal to 1. So a to the power of 0 is 1, x to the power of 0 is 1, y to the power of 0 is 1, 101 to the power of 0 is 1. Anything raised to the power of 0 is always going to be 1, right? So always remember that. Division. Division is the opposite of multiplication. So when we are dividing and the base is the same, check the base here. The bases are A. This is also a A. Right? Once these bases are the same, right, we subtract the powers. So with multiplication, we add the powers. With division, once the bases are the same, we subtract. Right? So when bases are the same, we subtract powers when divided. Right? Another way we could represent this is like an example 8, right? Same division. I just write it like a fraction, right? It implies the same thing as division. So x to the power of 6 over x to the power of 2, right? Is going to be x to the power of 6 minus 2, which is going to give me x to the power of 4. All right? So division, we subtract the powers. And that happens only if the bases are the same. Right? If I have something like, and I think we have an example of that right after. Right? Look at number 10. If I have something like this, a to the power of 7, b to the power of 5, this here you imply this as a division sign. Right? Divided by a to the power of 2 over b to the power of 3. This here means divide. And we said, once the bases are the same, we could subtract the powers. So we look at the a's by themselves, right? Because those two bases are the same. So we could subtract these two powers. There's always the one on top going first. minus the 1 at the bottom. So 7 take away the 2 going to give me a to the power of 5. 5 take away the 3 going to give me b to the power of 2. Right? And it's as simple as that. With the multiplication, if we have letters joined together like this, you work them out individually. So you look at the A's, right? These two bases are the same, A and A. So we can add those powers. 3 plus 4 is going to give me a to the power of 7. And then the B's, we do them separately, b to the power of 2 and b to the power of 1. Same base, so we can add those two. 2 plus 1 is 3. So I get a to the power of 7, b to the power of 3. And we know we could just join those together when we're doing algebra. All right? Is everybody okay with that? Anybody want me to look over any of the examples? If not, just put an N in the chat pod. Right? I'll take it if you right. So everybody good. All right, nice. So I have some for you to try on your own. Right? These you're going to do in class inside of your books for me now. So we have one set where set A, I'm looking at numbers specifically. Right? I just did an example with the first one for you. So 3 to the power of 4 means that I am multiplying 3 by itself 4 times. You're going to do the same with the others there for me. 2 to the power of 5, 4 to the power of 3. Remember the ones with the brackets, you're multiplying these powers here. Right? So for example, if I have 4 to the power of 2 raised to the power of 2, that's actually 4 to the power of 2 multiplied by 2. And that'll give me 4 to the power of 4. And then after expand this out and work it, that's like 16 by 16. 60, that's 96. Nine and 6 is 15. 256. Right, that's how you work out one like that. Right, on the section B side, you have 6 questions there as well. Those are with algebraic terms too. Yes, Shalice? Go ahead. You could use the chatbot or you could use your mic, whichever one you're comfortable with. Get private message too. Tell me if you don't understand any of them or you want me to do an example with any of them you have there. The last one, yeah, no problem. Let's scroll back up quickly. One sec, guys. Let's just recap there. So this last one, number 10, a to the power 7, b to the power 5 divided by a to the power of 2, b to the power of 3. With this one, it's division, right? This line here in the middle, which makes it like a fraction, implies division. So you're working it in parts, right? The A's are the same. So that's the same base here. So you notice I put the A here and I'm subtracting the powers. Because we're building on our rule that we had before. If the bases are the same, when we divide and we can subtract the powers. So I'm subtracting 2 from 7 here. Always the 1 at the bottom being subtracted from the power on top. Right? So that will give me a to the power of 5. So what I tell students is to do each letter separately. Right? So you match them. You look for letters that are similar. So I have a to the power 7 divided by a to the power of 2. So since those two bases are the same, I can just subtract my power 7, take away 2. and that is going to give me a to the power of 5. And then for the b's now, b's is the same. So I have b to the power of 5 divided by b to the power of 3. So I was taking the bottom index from the one on top, the bottom power from the one on top. So that's why I have here 3 from 5, and that's going to give me 2. So my answer here is going to be a to the power of 5, b to the power of 2. Right? So you're working it separately, but you're writing them together. So it's only look complicated, but you're actually doing each piece one part at a time. Yeah, make sense? Drop a 1 if you understand. All right, nice. All right, so I'm gonna just take these off. Go back to the questions. All right, so you're working these for me. When you finish, just type in a chat one, finish or done. So I know you finish working, and then we'd look at the solutions before we move on to the next part. If you're having any difficulty or you're unsure of any, you could always private message, all right? All right, so number 5 in set A, I have a few requests to look at that one. So for number 5 in set A, right? You had to look at things in individual parts when you're doing maths. The best way to approach maths is always to start from the simple and then build up, right? Those of you that are accustomed with me know that that's how I usually introduce our topic. We start with the little building blocks and then we could put them on top of each other and it would look like a big masterpiece at the end. So what we have happening here in number 5, you have to see it in individual components. We have this here is our power of our power, right? And this is just a normal 3 squared, right? I like to do easy things first, right? You get out of the way fast. 3 squared is 9, so I'm going to put the 9 here. I need to figure out what's going to come on this side. This, from what we talked about before, is our power of our power. And if we look at it by itself, our power of our power, no, this is not how you'd write it. Just explain it like this so you'd see the connection. You're multiplying the powers. You're taking 2 cubed and you're raising it to the power of 2. You are squaring 2 cubed. It's like you're multiplying 2 cubed by itself twice. So instead of doing that twice, we say we could just multiply the powers. Right? We could just multiply the powers. And that will give us 2 to the power of 6. And we work out 2 to the power of 6, which I believe is 64. Right? Check that very quickly. Just to make sure that 2 to the power of 6. Yeah, 64. Correct. It's 64. So let me write it properly now. And because that's the next thing. I want to try to write your maths in a way that's easy for the examiner to read. I always write comment down my page on the board here to save space I write going across. So when I do that now, I can see that working everything under each other. Underneath here, I'll put 2 by 3 multiplied by 2. Multiply by 3 squared, and we will call that to be 9. This we know is 2 to the power of 6 multiplied by 9. This is 64 multiplied by 9. Well, I'm running out of space, right? So I'm just going to write it here. 60 by 9, that is 540. And 4 9s are 36. So that is 540 and 36, 576 in all. Yeah? Everybody okay with that one now? Josiah, you alright with that? Shilis? Kima, Melanie? Jaden? Alright, take a copy, it's in your books. You all finished with both sets or still working? If you're not finished, just drop an N. Melanie finished. All right, so finish up and then we'll correct. So we'll begin to correct, right? So already answers in a different column. Here we're going to get 2 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 2. That's 4, 8, 16, 16, 32. Right? 4 by 4 by 4. 16, 40, and 24 is 64. Right? This is our power of our power. So you're multiplying this 2 by this 5 here. Get 2 to the power of 10. Now it works out to be 2 raised to the power of 10, 1024. All right, well, we did this one. This is 576. Everybody understand that? On this side now, these are more algebraic terms. Again, here, this is our power of our power. So we're doing 4 multiplied by 2. So that's going to give us 8 to the power of 8 to the power of 8. Here we add in powers. 3 plus 4, 7, m, 7 minus 5, that's 2, right? This one, like I said, you're looking at it in individual parts. So you do the A's first, you look at A by itself first, right? You add those powers, 3 plus 5, right? And then you look at the B, 4 plus 1. And now give it A to the power of 8, B to the power of 5. Yeah? Here, same thing again. Remember the line in between there is division. And you're taking away the bottom number from the top number. So 6 minus 2. And we have 4 minus 3 here. Now I give me A to the power of 4, B to the power of 1. But when we have a letter raised to the power of 1, we just write the letter 1. So you don't need to write it twice. We don't need to write 1 on top, sorry. Right? Here, anything raised to the power of 0 is 1. Multiplied by b to the power of 5. And 1 by b to the power of 5 is going to give us back b to the power of 5. Yeah? All right, guys. So that's our indices. Again, this will show its face when we're doing some algebra, simplification in algebra. Right? So we just touch on that here. Next, we want to talk about, I just want to rewrite this here, right? Because it's kind of in the way on. Like my work to the beach. Right. Good. So next you want to talk about expressing numbers as a product of primes. Again, you would have covered this at some point in time in maths previously. But it's a skill that you would need sometimes in algebra as well. So we're still going to talk about it again. So we have express 116 as a product of its primes. Basically, what you're doing is you are doing repeated division, but you could only use prime numbers on the outside. So you have to know your prime numbers, right? So I'm just going to do another example here so you'd actually see it as we work it out. Let's say we have a number 72. And we want to express 72 as a product of primes. So you always start with your lowest prime number, right? Which is 2. And if the number ends in an even digit, then you know you could start with the 2. So I'm going to start with 2 here. Now you're going to use 2 until you can't use 2 anymore. And then when that happens, you go to the next prime number, which is 3. Use 3 until you can't use 3 anymore. And when that happens, you go to the next prime number, which is 5, right? Or 7, and you continue in that kind of manner. So 2 into 72 should give me 36. Right? This is an even number at the end. This is a little trick that I need to know to help you to work things faster. So I can divide by 2 again. Right? This is going to give me 18. I could use 2 again because this is an even number. Now I can't use 2 anymore because we're at an odd number now, right? 2 can go into 9. The next prime number that I can use is 3. Now, not all the time it will go in that order, right? I could end up, let's say I'd end up with a 25 there. Then 3 can go into 25. So that means that I'll have to use 5. So you use the next available prime number. So in my head, I always try to follow that sequence. I go 2, then I check 3, then I check 5, then I check 7, then I check 11, 13, 17, 19, and I'll continue going like that. So I can use 3, and 3 into 9 is going to give me 3, right? And you continue going like this until you get to a 1 here. 3 into 3 is 1. Once you get to a 1, that's where you stop. Your answer now is written like this. You say 72 is equal to 2 by 2 by 2, right, by 3 by 3. And then you use the indices that we just learned. And you write 2 to the power of 3 multiplied by 3 squared. And this is how you could write a number as a product of primes, right? Again, this will come in handy when we're doing things like algebra. So it's just a tool that you need to know, right? And it comes under as well to your topic for computation number theory. So I have another example that I had written previously for you, right? Let's say 35. This is an example where I can't start with 2 and I can't start with 3. So the next prime number is 5. So I go 5 into 35 is going to give me 7. Then 5 is exhausted. I can't use 5 anymore. So the next prime number is 7. 7 into 7 is 1. So here 35 as our product of primes is going to be 35 is equal to 5 by 7. So for me now, you're going to do B, C, and D, right, as now. And for homework, you'll try E and F, right? So when I send this in the chat and in the Google Classroom, you'll go back and check this PDF document because you have some questions to the top to do, about 5 or 7. And then you have these 2 to do. So that's your homework for this week. All right, so you're doing B, C, and D for me now, just like we did this example here with 72, right? And this other one here with 35. Then we correct those and then we continue. Yeah? Everybody understand? All right, so just going to look at this quickly. So we're looking at LCM with the questions here. Find the shortest length that can be divided exactly into equal sections of length either 5 meters, 6 meters, or 12 meters. We said that this is a type of question that requires the use of LCM. We use prime factorization when we do the LCM. The difference is we are putting all the numbers together and doing it simultaneously. You start with the lowest prime number, which is 2. Numbers that aren't divisible by 2, I just continue writing them here until I could find a suitable number on the outside that could divide it. 2 into 6 is going to give me 3. 2 into 12 is going to give me 6. I will continue using 2 until I can't use 2 anymore. Right, at this point, I have to move on to 3. The idea is to try to get all of them to be 1s. Next one is going to be 5. Right, so my answer is going to be 2 multiplied by 2 multiplied by 3 multiplied by 5. That's 4. 4 3s are 12. 12 by 5 is 60. So shortest length to be divided is going to be 60 meters, right? It can be divided into 5 meters, 6 meters, or 12 meters. Right, everybody okay with that one? Number 19. Same thing, 35, 50, and 75. 50 and 75. LCM. Again, always start with 2. If you can't use it 2, then you move on to something else. Right, you try 3 next. To check to see if a number is divisible by 3, you can add the numbers or the digits in the number together. And if it is a multiple of 3, then our number can be divided by 3. So 7 plus 5 is 12. So I know that this can be divided by 3. Next, we use 5. 7, 5, 5, 7, 1, 1, Step one, 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 one. So our answer 2 by 3 by 5 by 5 by 7. 6 by 5 is 30, 30 by 5 is 150, 150 by 7. 70 and 35 is 105. Right, so this is the sum of money that can be divided between $55, $50, and $75. Right, a nice little statement. I just don't have too much space, so that's why I'm doing it like that. And the last one, gear wheel 25 and 60 teeth. Two again. 3. 4, 12, 60, 60 by 5, 300. We must turn 300 times. Right? So sometimes you get questions like that, either in multiple choice or in a structured paper. There's a section where they do a lot of critical thinking. All right, last thing now we're gonna look at is for today's session is going to be fractions with mixed operations, right? I am just gonna look at a few or maybe 1 or 2 questions from here, and you guys are going to do the others for me. So I cannot 21. I'm going to do some worked examples. I want you to look at the way in which I approach these, right? There's a particular way that I would suggest you approach your fractions when you're doing them. You're not using a calculator and you're working them out like this, then you should do it line on the line. The other thing is you want to convert all mixed numbers into improper fractions. So 1 multiplied by 3 plus 1, right? That's 3 plus 1, 4. So this is 4 over 3 multiplied by 1 by 9 is 9 plus 8. That's going to give me 17 over 9. Now we need to work this part out first before we can divide it by this other part here. But before we get to actually dividing, you always convert all mixed numbers to improper fractions. So 3 9s are 27, and 7 is going to give me 34 over 9. My next step is to do the brackets. So notice I'm going line by line by line. And I am working just as you would do when we're doing mixed operations with whole numbers or integers. We do just like that in parts. The next thing I need to deal with here is my brackets, right? So we're multiplying. Three by 9 is going to give me 27. 4 by 17, that's 40 plus 28, that's 68. Divided by 34 over 9. The next 9, change this division to a multiplication, flip the fraction, rewrite, then we could cancel. 9 is going to go into 9 once, 9 is going to go into 27 3 times. 34 is going to go into 34 once, 34 is going to go into 68 2 times. So we get 2 by 1 over 3 by 1, which is equal to 2 thirds. All right, always working down. You're doing it line by line, part by part. Let's look at another. Let's look at 26. 1 3/8 plus 1 5/7. Now they love to bring this question as a first question in any paper, be it the NCSC paper or the CSEC math paper. They always get a fraction question. And though it may seem easy, students still tend to get it incorrectly. 26. Now, again, always start by changing your mixed numbers into improper fractions. 1/8 is 8, plus 3 is going to give me 11 over 8. 1 by 7 is 7, plus 5 is going to give me 12 over 7. 2 by 7 is 14, and 6 is 20 over 7. 1 4 is 4 plus 3, and that's 7 over 4. Now, this is where we do some LCM, right? The lowest common multiple of 8 and 7, it's going to be what? 49, 56. So I want to use equivalent fractions to make the denominators here the same. What do I mean by that? I am looking at making the denominators in both fractions to be the same. To do that, I would use LCM. So I find the LCM of 8 and 7, which we said is 56. So to turn this 8 here into 56, I have to multiply by 7. And if I'm multiplying the bottom here by 7, I also have to multiply on top by 7. And to change this into 56, I have to multiply by 8. And if I'm multiplying underneath here by 8, I have to multiply on top of here by 8 as well. That's what's called an equivalent fraction, right? The fraction that I'm now going to write, which is 77 over 56, right, is equivalent to 11 over 8. If I divide these two, if I reduce this, I'll go back to the 11 over 8. So I am finding another way to write these fractions. 12 8s are 96 over 56. I am doing that so that I can equate the denominators. If the denominators are the same, then I could easily add my numerators. And I'm going to do the same thing at the bottom here, right? So here the LCM of 7 and 4 is going to be 28. So multiply that by 4 to get 28. Multiply here by 7 to get 28. And anything you do at the bottom, you have to do the same thing at the top. So it remains equivalent fraction. So I get 80 over 28 plus 49 over 28. And that saves me a lot of working because now I just need to add the numerators because my denominators are the same. 70 and 90 is 160, 160 and 13 is 173. Underneath we have 80 and 49, 40 and 80 is 120, 129. And then we could write this a little neater. So we have 173 over 56 divided by 129 over 28. And when we divide in fractions, we have to change this to multiplication and with the fraction. Tidy this up. Right, 1, 2 here. We could use say 1, 2, 3, 3. We could use 3. No, 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 okay. Think they have anything in common. Doesn't seem so. We get 173 over 2 by 129, 258. Right? Generally, I would leave my fractions as in proper fractions. I wouldn't convert them into mixed numbers. Right? I don't think we'd find any factors that could reduce those. And that's the method in which you'd want to approach the fractions. All right. You guys are going to attempt some of these for me. I will tell you which of these I want you to do. I'll put some circles around it and I'll send it in the group chat a little later. Those are the 5 questions from the set you'll do for homework for me. All right, so as I mentioned before, this document, I will download it as a PDF. Right, let me do that one time. And I will send it inside of the WhatsApp group chat. And then I'll upload it to the Google Classroom as well. Until later today, I'll get it into the WhatsApp group chat. And by tomorrow morning, you should have the link to join the Google Classroom with your recording, your PDF, and your homework. All right, guys. Any questions before we go?